All right, this week we're going to focus on two-step equations. I know that in sixth grade you did one-step equations where you did either you did an inverse operation to solve for usually x, an unknown. To recap, sorry, this week you are responsible for 3 more lessons in Imagine Math. It is the solving and modeling two-step problems, solving two-step equations, and modeling, evaluating, and graphing two-step inequalities. My suggestion to you is to do these first 2 before Thursday, because Thursday's live lesson is over the inequalities section. So it'll make more sense if you're ready to move on to that section. Some vocabulary to remind you of. A coefficient is the number that is touching the variable. So in this example, it would be the 2. A variable is the unknown that you're solving for. For us, it's usually x, but they are allowed to use any letter. The constant is the amount that's being added or subtracted. It has no variable attached to it. So it's the numbers that you've always been working with. Inverse operation means to do the opposite to create a zero pair. So you reverse the operation that's happening. And then a reciprocal, you don't use this in every example, but if the variable is either attached to a fraction or part of a fraction, then sometimes you have to use the reciprocal, also known as the flip of the fraction, in order to solve. All right, so something that you may have seen last year when you were solving was algebra tiles, meaning that you have these that represent x, and if my equation is 3x plus 4, then I need 3 x's, and then I need 4 individuals, and I prefer the clone button because I make a mess when I try to do this. And then on this side, we're going to need these 10 individuals. Currently, none of them are negative, but if I needed them to be negative, I would hit this negate, and it would change it to a negative. But currently, I'm just trying to make 10 of them. 6, 7, 8, 9, 10. All right, normally I'd move them and make them all cute, but I don't want to mess up the screen. It kind of gets crazy on me. So currently, to solve, I need to get x completely by itself. So my first step is going to get all of these individuals to the same side. So if I have 10 over here and I have 4 over here, how can I get these 4 to come join over here? I'm going to do an inverse operation. So if this is plus 4, I'm going to subtract 4, which in this case just means add 4 negatives. And do you remember what it's called when I have those 4 negatives? It's called a zero pair. So this one and this one will zero each other out. This one and this one will zero each other out. This one and this one will zero each other out, and this one and this one will zero each other out. However, in an equation, both sides have to stay equal. So what I do to one side, I have to do to the other. So if I subtracted 4 here, then I also have to subtract 4 here. So that creates more zero pairs on this side. This is a zero pair, this is a zero pair, this is a zero pair, and this is a zero pair. So technically I could erase all those and get them out of the way. I'm going to move the ones that are left up here so we know what we're working with. We have 3, 4, 5, and whoop, I need just this one. 6, okay? So now I'm left with 3x equals 6. Technical difficulties, my apologies. So if I were to separate this side into 3 equal groups, could I do that? If my computer will let me, I can. How many ones will go to each x if I break these down into 3 equal groups? Correct. That's what we're solving for. So 1x equals 2 1s. Don't worry, I'm not going to make you always solve with algebra tiles because I know sometimes It can be frustrating, especially on technology because it takes forever. So in this case, our x equals 2. And I'm not very good at drawing on my screen. If I wanted to go back and check, I could plug in 3 times 2 plus 4 should equal 10. 3 times 2 is 6, 6 plus 4 is 10. So in equations, you can always go back and solve to check your work. We good so far? All right, stop me if you have questions. All right, so here, I'm gonna do this without the algebra tiles. So I have negative 5x minus 6 equals 10. Last time we started with this constant. The constant is the plus or minus at the end of the equation. So if it's minus 6, the 0 pair would be plus 6 to make that equal to 0. And what I do to one side, I must do to the other. So then I'm left with negative 5x equals 16. Then I'm going to try to separate the negative 5 and the x. How do you separate them? Well, what's happening to them in the equation? It's being multiplied, so the inverse operation would be to divide. What you do to one side, you do to the other. And you should have done one-step equations with everything from multiplication, division, addition, and subtraction last year. So now we're just putting all of those things together. 16 divided by negative 5 is going to give me a negative number. I don't know that number, so I'm going to divide. And that gives me 3. Bring down the 1, add a decimal and a 0. 3.2. So negative 3. Whoa. My screen got crazy on me. Sorry about that. 3.2. Now you could plug it back in and make sure it's right. I just don't want to run out of time on all our examples. I am okay with you checking your work with a calculator. I just prefer that you do it by hand first to make sure you understand the process. All right, so here's another one. My constant is at the beginning. If a number is at the beginning of the equation and it doesn't have a negative, it's positive. So the inverse of a positive is to take away. So I'm going to get rid of my constant first by doing the inverse operation to both sides. This side will cancel out. It creates a 0 pair. I'm left with negative 2x equals. And some of us are a little fuzzy on our integer operations. I noticed that when I was helping students with their work. Be sure that you double check this, because think about it as money. If I owe you $12 and then today I borrowed 10, now I owe you $22. Some of us get those confused because we're thinking of subtraction. Last step, to separate your coefficient and your variable, you're going to divide by negative 2. A negative divided by a negative makes a positive. And then 22 divided by 2 is 11. All right, our next example involves a fraction. Don't stress about the fractions. They're very easy to work with, okay? First, we want to isolate the x. So we want to get the x completely by itself. So we're still going to start the same way. We're going to get rid of that constant by inverse operations. So positive 6, negative 6, create a 0 pair. Then we're left with 1/2 x equals 28 minus 6, which is 22. And then we're going to try to separate the x and the 1/2. Technically, it's being multiplied, but you can't divide by a fraction. So we multiply by the reciprocal, which means the flipped fraction. And what we do to one side, we do to the other. Okay? So these create 0, or 1 actually, and they cancel out. So we have 1x. 22 times 2 is 44, divided by 1 is 44. And then that would be our answer. If I got a number like 44 on an equation question, I would probably go back and check my work. What's half of 44? 22. 22 plus 6, 8. 28. So it works. Our last example for today is x divided by 8 minus 1 equals 4. So we're still going to start with this constant and use the inverse operation. So what I do to one side, I have to do to the other. This side creates a 0 pair, so it is gone. Then we have x divided by 8 equals 5. Okay, if x is being divided by 8, the inverse operation is to multiply by 8. When I do that, I have to do it to both sides. 8 times x is 8x divided by 8 is 1x. So the 8's actually cancel each other out. So then I have x equals 40. I would go back and double check to make sure my answer is correct. 40 divided by 8 is 5. 5 minus 1 equals 4. So it works. That concludes our solving equations lesson. You're welcome to sign on for, or stay on and then sign on each day at 11 for my office hours where I can help you with the exact lessons from Imagine Math.